Everything is ready. We have created the dictionary federalist by authors, which contains all the data, where key is the author's name and the value is the author's data. Now what we have to do, we have to create a words distribution, word length distribution exactly. So we'll count the word with a particular length, we'll count them and we'll create a graph out of it. So let me create a tuple named authors, and the first one is Hamilton, second is Madison, third is disputed, then we have J, and the shared documents. Okay, my tuple is there for authors. I'll create two dictionaries, author tokens okay. Let me explain these dictionaries. Let me create first. And length distribution. So what I'm going to do, I'll go through all these authors, and whatever dictionary I created in this dictionary, the key value is the author's name. You can see all this author's name are exactly the key values here. I'll take the string, the data contains everything, and I'll remove all the punctuated things, other letters. Only the words will be there. I'll take only the words, because what we want is the word and their length. So what I will do, I'll create a loop for author in authors. Authors is my authors list. Yeah, me. Tokens is equal to, I'll create a token, is equal to NLTK dot, there is a method for it, word tokenize. So what it does, or it takes a string and create tokens out of it. I mean, each word will be each string, each tokenize. So everything, for example, punctuated letters, words, everything will be tokenized. Tokenize what? I'll take the data. So data is present in this dictionary federalist by author, and I'm taking for each author. This, oh, I didn't import NLTK. Import NLTK. Okay, so this is done. After that we'll filter out the punctuations. For that there is an NLTK library for it. So I'll take the author tokens as okay. So the dictionary I created, okay, and the key value will be the author. And now here's a tricky part. I have to remove all the punctuations here, so I'll do it in a very small code. So let's see this first. For token in tokens, you know what tokens is here, okay. If any, now here it is c dot alpha. This is a function for c in token. So what I'm doing, for each token in tokens, I'm checking whether it is an alphabet. Is it made of all the characters only, or not any other special characters or numbers, something. If it is only alphabets, then I'll create a list of it. Otherwise I'll discard it. So for token in tokens, put the token there. So put that token in this list. That's it. So this line is nothing else. You can do it in another way also. I just wanted to put it in a single line. So for token in tokens, if it's an alpha character for C in token, whatever token I am getting here is a string. So for C in token means all the words in this string. If it is made up of only alphabets, I'll put this token inside the list. Otherwise I'll discard it. So this is done. I got the words out of the for each author. Now I just have to calculate the length of it. So token length which I created token length. Okay, token length will be, again, let me just write it again. For token in author tokens of what authors, for token in author tokens for token, put what length of it, the token. So I got the look. I'm iterating over all the words which I got for each authors, and I'm just getting the list of lengths. That's it. Great, I got the list. After that, I want to get the length distribution of author. So I'll create a list out of it. Length distributions authors. Okay, and I'll call NLTK dot frequency distribution. This is the function name, and I'll pass the token length, and I'll just plot length distributions, okay, of author, and let's just plot it. So maximum length I'll put as 15, up to 15 words, length of 15 words, sorry. Title is equal to author. Author means what? Whenever it will plot, it will show for which author this plot is. Sorry, this dictionary is length distribution, not distributions. Yeah, that's why it was throwing the warning error. So now it's fine. Let me just make it a little bit big. I just run it. Okay, I'm getting some error. Str object has no attribute alpha. Oh, sorry, I just should be is alpha, because I'm checking whether it is an alphabet or not. Okay, let me run it again. Okay, you can see the plots here. You can see there are plots for Hamilton, Madison, disputed, and J, and shared. So there are exactly 5 plots. There are 3 authors: Hamilton, Madison, and J. The shared plot is for the documents which were shared by Madison and Hamilton, and disputed are those which we don't know. Now see this. See the plot. It looks exactly almost same, but it's not exactly. If you see the plot of J, the samples are the word count. I mean, there are 2 words, 2 length words. There are 1200 words, around 1200 words of length 2, and so on. It goes, distribution goes like this for J. It's definitely not what this disputed plot is. It means that whatever the documents are there in the disputed are definitely not written by J. You can see there the beginning and the tail is definitely different for J and the disputed. But if we see, and also if you see the shared one, it looks similar to Hamilton more as compared to the Madison one. But if you see the disputed one, you cannot say who exactly wrote the disputed ones. Either it is Madison or Hamilton, but you can definitely say that J didn't write. You can see the plots are different. The beginning part is a little bit similar to the Hamilton one. You can see the beginning of this plot of disputed, but the tail is more or less similar to Madison or even Hamilton, so we cannot even generalize with this. But this is a very fun way of seeing what exactly is going on, or is it anyway related. With this, at least we were able to say that this J definitely didn't write these disputed. This analysis was given. When it was given, it didn't account for the author's way of writing things, how they choose words, what kind of words they choose. They're different. There are so many research on this, and it's still a hot area. So people are still working on the stylometry, and now there are so many tools through which you can analyze the author's signature, and you can predict or you can categorize authors documents by analyzing their styles. So it has so this what the program we did with was just to motivate you with this idea of stylometry. You can exactly actually, given a document, you can do some analysis and get the author's name if you have previous data of it. So this is exactly known as data analysis nowadays, where you have a lot of data and you analyze the data, and you, whenever you get a new data, you try to infer from the past data whether this new data is means something or not. So this was a very naive example of doing it, because this was the quickest and simple way of doing it. If you go a little further, it will become very complex. So since this is a very basic course, we didn't want you to go through the complex ones, so we did this basic analysis to understand the data at least, and we can see the plots, and we can at least infer something through this. There are so many other methods of doing stylometry. You can go to the web and you can just type stylometry, and you will get a lot of way. Please see this NLTK library. This is a very good library for analyzing text documents. Actually, it is known as NLPK, NLP analysis. So please see this libraries. If you have any problem, please post it on discussion forum. Thank you.